Today's presentation. These two gentlemen on the call with me, John Gunter and Ty Noble. John's with Frontiers North Adventures. I think sure a lot of you know him and his company. They run tours up in Churchill, but not only tours, but they have developed their own manufactured Tundra Buggy lodge system that they haul out to the tundra, and they take guests out there, and they're on a path to greening their vehicles that are out there, and they've done some amazing work. And what I find fascinating is that they're running in -50, -60 degrees C's with battery electric vehicles now. And I'm sure there's some interesting lessons that can be learned for those of us that are on road or ag or those sorts of things. And then Ty Nobles with Noble Northern, they are the technology arm, if you will, of Frontiers North. And they're John and his team, they've got the dream that they want to be as environmentally sensitive and responsible as possible. And it's Ty and his team that are the ones that are turning the wrenches and cutting the steel and welding things together in order to make that dream come true. So with that, I'm going to leave the presentation here to John and Ty, and they're going to take us through how they use the equipment, where the equipment's used, kind of the experience. And I'm sure at the end of this all, we're all going to want to book tours up to Churchill. And yeah, and then Ty's going to talk a little bit more on the technical side about the use of the vehicles and how they operate in zero emissions, but also share with us some of the other things that they're doing in order to reduce diesel fuel usage and propane usage and that sort of thing. So with that, I introduce John and Ty. Take it away, guys.
Thanks, Ron. If just to get the ball rolling here, I'll try and just maybe set the stage and provide some context as to where we're operating, the conditions in which we're operating are really our business goals. If we're not meeting the needs of our consumers, it's really difficult to pay for this stuff. So I'll try and present a bit of the business case here for us. So quickly in Churchill, Churchill is a northern community. It's not necessarily an indigenous community, but Frontiers North operates and hosts guests on the ancestral lands of the Cree, Dene, the Inuit, and the homeland of the Métis people, and Churchill's in Treaty 5 territory. Ty, do you want to jump in here? Actually, okay, yeah. So we've got a bit of, yeah, you give her here, Ty, sorry. Just we organized the slides here, sorry.
No. So Noble Northern is kind of morphed over the years to be quite diverse. We do a lot of work with Frontiers North, obviously our biggest client. We take care of their vehicles in Churchill. John had a good idea to go EV, and with the VTC and Red River College's help, we were able to come up with an EV Tundra Buggy. We're now on our third one with John's support here, and some other things that we do for the rest of the year. We do build modular off-grid power and water solutions. We're a fairly big supplier to some northern communities, but mostly Parks Canada, from Yukon all the way to Labrador. A lot of extreme remote systems. We have done a fair bit in Lake of the Woods. And we do, the majority of our work is, and always historically has been, steel fabricating. And we're slowly starting to get into the eastern mining world. There's some lithium mines that we're taking care of on some of the power and water solutions out there. This picture here is a newly developed product that's going in a EV school bus. Take the motor transmission out, and this power unit goes in. That we're presenting on a little bit later on, but just a couple of our projects. Anything in this picture that's red, for example, is an addition, no new holes. Battery box drops in where the motor and transmission came out. It's quite an easy conversion. So we're just more of a, we're not quite an R&D shop, but we do a lot of fabrication that has morphed us into moving towards the EV world. These are just a quick power unit that we came up with for northern Quebec. It just, the only reason why we put this up here, it kind of ties everything together. We do a lot with lithium batteries. Some of our battery suppliers are in China, some are in Canada. The ones in Canada are bringing lithium from the opposite side of the world. And this is a new mine up in northern Quebec, which isn't far from the battery manufacturing plant. And it's in exploration right now, but ties it together. This is the power system for the camp and mine at this point.
Thanks, Dave. So when we talk about a bit of a business case as to why we invest heavily in these forward-looking technologies is about what we perceive to be our own role in the stewardship of the community of Churchill and the environment surrounding Churchill. So in the corner here, you could see we're a certified B Corp, and that basically means using business as a force for good. And when we look at our business, our single largest greenhouse gas emitting parts of our business were our fleet of Tundra Buggies. So we kind of address that. So just quickly a bit about Churchill, why we're there is a really interesting overlap of ecosystems in Churchill, resulting in a very interesting overlap of wildlife, marine mammals like polar bears and beluga whales, and land mammals, everything from wolverines to foxes to caribou, you name it. So there's just a lot going on in Churchill. Frontiers North we're just a travel company. And over the years, what we started just as expediting trips to Churchill, which means we didn't really own anything. We contracted all of our services. And over the years, we just kind of like a hungry hippo, we've kind of acquired some businesses over the years and brought more and more of our operations under our own umbrella. The idea here is that we're operating these multi-day guided group trips. And when our guests are arriving from all over the world into Winnipeg, we're providing them these multi-day trips up to Churchill for winter northern lights during February and March, summer beluga whales during July and August, and autumn polar bears during October and November. So there's a quick 1-minute video here that I think we'll play, and then we'll get down to business.
For centuries, Polaris, the North Star, has depicted True North, a navigational reference for adventure-seeking explorers. Our True North is an unwavering passion for Canada's extraordinary wildlife, breathtaking landscapes, and warm-hearted people, forever leaving their mark on all who travel here. We consider it a privilege to share this awe-inspiring land. Join the adventure and find your true north.
So as you can imagine, consumers that are interested and willing to travel across the world to experience what we have here in northern Manitoba they're coming here on purpose. It's very intentional, and from a consumer standpoint, there you go. From a consumer standpoint, it's our guests that are holding us accountable and demanding a certain way of operation from us. So we're just trying to stay ahead of that. We'll quickly cover today this remote lodge. So here we are. Okay, but before we get into that remote lodge, so this is the EV Tundra Buggy project that we've been working on between Noble Northern and Frontiers North. We started this project in 2018, just kind of thinking about maybe this is possible. We're in a position where we've got this fleet of 12 Tundra Buggies, and the undercarriages were reaching their end of life. We had to do something with them, and we were either going to replace the diesel frames and suspensions and the sort of like legacy axles that were there, or we were going to do something new and different. So from 2018 to 2021, we basically invested in the research and development to introduce our first EV Tundra Buggy. And a bit of the stats here, how we've gone down, so we're zero emission propulsion. The carriages or the cabins of these vehicles, the bathrooms, the bathroom basements, and the battery boxes are still heated with ProHeat units. So we dramatically reduced our diesel consumption per day per Tundra Buggy, and at the same time reduce the cost to operate these in terms of fuel. And as well, these EV Tundra Buggies just require a lot less maintenance than our legacy diesel fleet still does. So yeah, as I mentioned, we've completed 2 already. We've got our 3rd in the Noble Northern Yard in Headingley right now, and with the goal of getting it completed and up to Churchill this summer. And we hope to complete the conversion of the fleet by 2030. This last bullet point here is as you know, when you start any sort of diesel machine that's been not moving overnight, and you got to pull it away from the dock in the morning, regardless if it's been idling for 90 minutes or not, to get that machine going from a static position to a moving position. It takes a lot of energy to get it going, and just the roar of the diesel engine and the competition between our guests communicating with each other, our guides communicating with our guests, it just sets the tone for the day when it's that loud and that aggressive, compared to silently pulling away from the dock, conversations not being interrupted, guides not having to raise their voices in order to communicate with people. It just sets a completely different tone for the day, which is an interesting business goal that we get to accomplish here. So for this, mention the Tundra Buggy Lodge. So this is what the Tundra Buggy Lodge looked like in about 1982. Over the years, this lodge, if you can call it that at that time, has just been iterated upon and improved upon year over year. And let's see here. So this is what it looked like a couple years ago. Starting at the bottom left here, we've got 2 accommodation units. We've got a lounge car with a rooftop observation deck. You can see the skylights in the lounge and in this dining hall. And then what we're looking at in particular, and what we'll talk about today, is how in the last year, we've replaced this legacy kitchen, this legacy generator trailer, and the reliance on propane. So historically, we've had these 2 generators, a primary 56 kilowatt and a backup 40 kilowatt generator that had been, one or the other had been running 24 hours a day. And I think the big thing that we honed in on here is that there were periods of the day where we were, there's a full draw coming off those generators, but most of the day they weren't running efficiently. And I don't know, Ty, if you have any more sort of technically to add here, but it just wasn't efficient. We were wasting a lot of fuel, creating a lot of, just required a lot of maintenance, a lot of labor, and a lot of money to operate inefficiently. Anything to add, Ty?
No.
Moving right along. So here was the opportunity. We knew that we had to end of life this kitchen and generator setup. So the opportunity was to optimize the generator loads, to capture the engine heat that for almost 40 years had been thrown out the window, to eliminate the reliance on propane for heat, reduce our diesel consumption, reduce noise on the Tundra, reduce our greenhouse gas emissions, and address that consumer need of guests. We don't call ourselves an ecotourism or sustainable tourism company, but that's sort of like, just to sort of paint a picture, that's the expectation, that guests are coming to these places in the Canadian subarctic expecting a certain thing. And when there's diesel generators running 24 hours a day, we're not necessarily meeting that need of helping our guests connecting with nature and wildlife. The solution that we came up with was to combine the kitchen and generator trailers to capture the engine heat to warm interior spaces, and to rely on silent battery electric to power the entire Tundra Buggy lodge most of the day, reducing generator runtime, reducing diesel consumption, and reducing propane consumption. So a couple notes here, and Ty, jump in whenever you feel comfortable, is still using propane to power kitchen appliances, a couple kitchen appliances. So we haven't completely eliminated propane, but we've dramatically reduced the use there. And the diesel generator is still running about 6 hours a day is kind of what we're thinking, but getting away from having to rely on those diesel generators 24 hours a day. Ty, do you want to jump in on this slide?
Yeah. So a big part of diesel engines, especially the Tier 4 final emissions controls with EGRs and that's what we have, and it's very common to have wet stacking, which is where the EGR clogs with carbon, basically because it's not burning hot enough to burn the carbon through the EGR. The EGRs clog, you have major breakdowns, huge cost issues there, as well as the efficiency of these engines is widely published, and in terms of like the kilowatts, it's usually around about 80% load on that engine is when it's burning the most efficiently, and that's what we're doing. So taking the size of our battery bank, taking the load on the rest of the lodge, when this generator is running, we're able to, because we can control exactly how much charge we're taking off of it, we're able to supply the lodge with the load for dishwashers, and that it's quite a big load on a commercial dishwasher. So at dinner and breakfast, it's best to have the generator running. It's a intermittent heavy load. So that's when we automatically adjust the charge rate of our batteries. So we're keeping our Tier 4 diesels in their most efficient curve, which is, it's burning diesel, but it's burning it the most efficiently, according to the manufacturers. And we get away from the wet stacking, and we put those engines where they want to sit, where they want to run. The 4 Exalt batteries they're under the kitchen, they're basically the same battery box that's under the rest of the EV Tundra Buggies is under the kitchen. So it's all of these battery boxes drop down. There's 4 pins that pull out, they drop out. We can swap them anytime. There is a big part of getting rid of the propane heat in the kitchen here was taking all that generator heat, especially when they're running at a high load level. They're creating a significant amount of heat, and we're taking a lot of that heat and we're putting it into, we have basically a large hot water tank that's custom made to fit in this room, as a lot of things were, because there's a certain footprint we had to be able to use. It has a lot of different layers in it in terms of stratification and heat levels. So, our hottest water is going to be up near the top, and we have heat exchangers. It's a fairly complex but simple system of pulling heat from the engine whenever it's on, heating water first, due to the water takeoff being at the top of the tank, and all the way down priority levels down to there is still an outside deck for where our fuel storage is. That when the engines start to need to disperse heat because the tank is getting too warm, that pump turns on, and there's a floor heat in the outside, which just keeps the outside area of the kitchen melted. There's no shoveling. It keeps the propane warmer, and that heat is going to be blown out a radiator anyway. So once that lower area of the tank gets to a certain temperature where it's now going to start to overheat that engine, then the radiator turns on, and the radiator is below the floor. So there's several layers of heat recovery on here.
So we just got some pictures of the build here, and Ty, if there's anything interesting or sort of noteworthy to point out about the build. So as we go along, you'll notice that like this finished painting on the frame here, this represents the back deck on which the fuel sits. There's the next room. So this whole unit contains this, essentially that generator room with the hot water tank and the battery management that Ty was talking about. Suspended beneath this is where that battery block lives. And then this on this right half, this is more that kitchen area. So this was sort of the business need that we needed to fit all these functions into this one unit that is similar in engineering to the rest of the Tundra Buggy Lodge.
And you can see it's sort of a bridge. It's almost a bridge engineered bridge structure here. It's due to the terrain that this thing has to get pulled through. A lot, like these are 5 foot tall tires on here, flotation tires. They will be dropping into holes that are, well, we've seen over 4 feet tall. So we sometimes have to hook up a few buggies to pull this back through. There's a lot of, it gets pulled out in pretty good conditions at the end of September, at the end of November, beginning of December, when it gets brought back to Churchill, about 30 kilometers away. It can be some pretty serious terrain. So this unit here had to be built quite strong, as you can see. There's a lot of insulation value here as well. There's 8 inches in the floor, 6 inches on the roof, and 6 inches in all the walls. So we keep our heat recovery to a maximum. This is the floor. So there's a lot of different loops, like I said, off the stratification layers in that hot water tank. That's the outside deck there. That will just be glycol that runs through there, and that's the same throughout the entire unit. Different loops, different pumps, different takeoff levels, but that's the idea. For what we had to come up with for a material that can take extreme cold and then extreme heat. So we have 5/8 wood there that's the same height as the pecs, and then we have aluminum that's mated right down, which is basically our heat dispersal. On top of that aluminum, it's a sprayed in. It's a different type of material. It's not a box liner per se, but it's similar. But it can take the temperature swings, which will be plus 30. This thing is going to operate in the summer, and in the winter it's going to be minus 40 out. But there's going to be hot water going through it. So all of those had to be considered here.
And the loops, the different loops. So there's this exterior. Well, so what's the priority? The priority is it goes into the kitchen first. There's 2 loops into the kitchen.
And any of them can be prioritized. There's 3 different pumps. There's a pump that turns on when the kitchen needs heat. There's a pump that turns on when the hallway needs heat, and there's a pump that turns on when the exterior needs heat, which it never needs heat, but it's just a way to cool down the generator that's somewhat useful rather than blowing it out a radiator. And those are just off the shelf Grundfos hydronic circulating pumps.
The hallway that you mentioned it's a interior space. but not necessarily. We're not necessarily concerned about that being like 20 degrees Celsius. It's just above zero.
That's an overview of the battery box, what it looks like underneath the unit here. There's a lot of components in there that obviously wasn't finished at this time, but that's what it looks like.
And are these the Exalt batteries, Ty, or are these the Cattles?
Cattles.
So this box would go, so it's the box itself, like the exterior dimensions of the box and the pins to raise and lower it are uniform between all of the Tundra buggies and this. And I wanted to, you know what, I'm going to scoot back a couple slides here because we didn't, I just didn't have room to write it out. So diesel electric hybrid combined heat and power unit is this DEH-CHP. So between the power unit and the touring Tundra buggies, they all have the same type of battery box and type of connection. So those can be swapped out if they need to, but we haven't. There hasn't been a need for that. I think one of the interesting points to make here, since we're talking about batteries and the concern about batteries in the cold, is like Ron mentioned earlier, in particular, not just sort of a few months ago, but about 14 or 15 months ago, during our Northern Lights tour season in Churchill, ambient temperatures were hovering around -50, and combustion vehicles either weren't starting or weren't staying running, and our EV Tundra buggies were. I don't know, Ty, do you have like an anecdote that you can share about what it was like operating in those temperatures?
Yeah, I mean the comparatively they're not block heater per se plugged in, but even in the most extreme temperatures, this last February, March, I don't think we get past -38 ambient. The wind chill was something we don't talk about, but the ambient was, yeah, -38. Anywhere above -30 is where it kind of hung around. And as both of the EVs were being used all day, every day, and they were parked back at the end of the day to charge, at no point were the batteries heated during this entire last month and a half of use. They were always dispersing heat because they were always charging. So in this particular battery box, there's about 220 kilowatt hours of usable energy in there. The charger, which is in the bottom, the corner closest to you, that's an 18 kilowatt charger. It produces around 1.5 kilowatts of waste heat, which is sharing its glycol loop with the piece that's right next to it, which is the motor control unit. There's two of those because there's dual motors. And then there's a DC to DC converter, which is like a 700 volt DC to 12 volt DC, which also creates about 500 watts of heat. So at any point, the batteries, the charger, and the DC to DC converter are all creating energy. They're creating heat, and actually quite a bit of thermal energy that we're able to store in a well-insulated box. But during the charging time, we're always dispersing heat, and they don't create a whole lot of heat when they're driving. The only item in this box that would create heat when it's driving is the motor controls and the DC to DC converter. The batteries create very little heat from what we've discovered. So there's basically no heating when we're driving because there's enough thermal storage and it's well enough insulated. And then when it's sitting and it's charging, it's always dispersing heat. So it's impressive to be able to say that for 6 weeks of the most cold temperatures we're going to reach, that we didn't have to heat this entire battery box.
And so, Ty, if I got this right, these battery boxes are plumbed into the same loop as the heating for the carriage and the potable and wastewater underneath the bathroom. But this loop of that, or this segment of that loop, has never called for heat. Is that right?
No, each battery box they are able to be disconnected completely without disconnecting any hoses, and that's why we didn't combine them. We didn't want, if you had to drop it off, to have to
Got it.
pull hoses apart and that. So this has its own individual heater. It's a little Webasto Thermotop C. You can kind of see it in the top left corner there. And we have runtime timers on that to see if it did run. But that one is basically an emergency heater. If this buggy was to ever sit for 2 or 3 days without needing a charge, eventually that temperature is going to get to it, and it's going to turn on for. It turns on for approximately 5 minutes every half an hour, just to give it a little bit of a boost. And we like to keep these batteries anywhere from 5 to 10 degrees Celsius up to below 40 is where our temperature range is. And there's very little noticeable difference in the performance in our case, depending on temperatures. We see it maybe has a little bit less overall range if the batteries are closer to the +5 to 6 temperature, but it's very rare that they are, because once you start driving, they get warm again. So that's our thermal part of the battery box.
So we're just we're making an information sheet about these EV Tundra Buggies to put some stuff in context for our guests, and we're goofing around yesterday, and we discovered that for each EV Tundra Buggy, or each EV Tundra Buggy has about the equivalent of 2 Tesla Cybertrucks in kilowatt hours batteries. And then in terms of MacBooks, 3,400 MacBooks, and in terms of iPhones, 18,490 iPhones, the equivalent battery power in an EV Tundra Buggy. So we're trying to figure out how to make this, how to make all these technical ratings be relevant and make sense for, a regular person. So this, in the back corner here, Ty, this is that water tank that you're talking about. It's behind this false wall here.
Yeah, so this is more of a almost a progress picture at this point, but it looks a little different now. But in that back corner there, you can kind of see the heating loops. All the copper coils. The tank is full of glycol. Those are the 2 engines. As you can see, there's no radiator on them. The cage is not over them in this photo, but the radiators are below the floor. The exhaust is below the floor, just to get as much sound as possible out of the interior, and any heat generation or any heat dispersal. There's no point in having a big hole in the wall. We just pipe the glycol through the floor, and the radiators below the floor. And then up on the wall, you see a propane hot water tank. That is if the engines are not running, we're on battery power, and the stratification levels in that hot water tank are not hot enough, that automatically kicks on. So propane hot water tanks on demand, they get a input temperature of the water, and they try to make that equal about 48 degrees on the output. We're always going in at hotter than that, and then we have mixing valves. But this propane hot water tank is only as a backup. It's just a redundant heat. Very little has it ever turned on, because the cold water per se coming into it is actually hotter than it can make it. So it's just another redundant piece in case there was ever engine failure, or again when during the day there's a lot of dishes being done possibly, and you're running on battery. We don't have to start the engine just for heat. That's kind of a picture before it left our shop, just about finished. You can see the battery box is the black box underneath, and then right behind that is a lot of water and sewer storage. There's a washroom in the kitchen, and there's a complete commercial kitchen water system, meaning the entire output and input of the water. It is all fresh water from a local stream, which is also treated to drinking level in the kitchen itself.
So here it is on site on the Tundra, about 35 kilometers east of Churchill along the coast. And to the left, the unit on the left is a staff quarters. The unit that we can see in the middle here is this power unit that we've been talking about. And the unit on the right of is the dining hall. So this is what it looks like when it's all set up. And so it just sort of note here, this is a service vehicle that is doing the retrieving potable water every day, or not every day, every few days, I suppose, hey Ty. And actually, that's a good point. So one of the things here that we've managed to do is reduce the number of service runs with the support vehicles. Do you want to quickly chat about that?
Yeah, so on the other kitchen, we didn't have the room, nor did we have the frame capacity to hold as much water. So we go from town out to here to haul the wastewater from this lodge back to the town to be treated with the larger tanks on the kitchen, which is the primary user of all the water on the lodge. We're able to stretch that from every second day to every fourth day, which is significant when we're taking a service vehicle over the land that far. In terms of pull out and pull back, we also deleted 2 trailers, so it's a fairly streamlined pull back and setup now, as we need 2 less people to drive 2 less vehicles with trailers behind them.
So the 2 less trailers are combining the kitchen and generator trailer into one unit that we've been talking about, and eliminating that propane trailer that had 4 1,000-gallon propane tanks on it. And so now we're just essentially we're hand bombing those 100-pound propane tanks from the service vehicles onto the kitchen for the kitchen appliances. And then, yeah, so this is where the magic happens. This is what folks are traveling all over from around the world to see. So this is from the dining hall, looking back into that kitchen. And then this last picture here, I think, is just, a crappy iPhone picture. It's all that I had, but just to kind of show the guest experience and a bit of the business case of why making these investments in diesel, electric, hybrid, combined heat and power units for our remote Tundra Buggy Lodge are important for us. There you go. Thanks for your time. Ron, how do we do?
Fantastic. Yeah, so if anybody has any questions, feel free to use the Q&A feature on the bottom there of the Zoom, and yeah, we'll get to your questions. We got one question already. Is I guess this is, you could answer this question too, depending on whether you're talking about the power unit or the kitchen unit, but how are the electric batteries recharged? What's the runtime? And is there any move to consider solar for charging?
So in terms of how the electric batteries are recharged, so we are at the kitchen itself. That's being used as basically a load bank for keeping our generator in our efficiency curve. That's how those batteries are recharged. So anytime that generator is running for a heat recovery, those batteries are taking charge from that generator. The runtime on the lodge itself, we have approximately 18 hours of battery. That's obviously not when it's at full load, but at full load, the generator is running. That's when we need the reliability there. the runtime and charging on the EV Tundra Buggy. We have a 0 to 100% on a Tundra Buggy will take about 12.5 hours with an 18 kilowatt charge. Very rarely would it ever get that low. That would take 2 full days of driving. So it's usually, 7 to 8 hours. These are always parked for approximately 16 hours a night. So there's never an issue with not having full charge. They are charged. Manitoba Hydro is very close by in Gillam. They got obviously a line running right to Churchill, so it is charged off of the Manitoba Hydro grid at either the Northern Lights location or the Polar Bear location. And as far as solar, there is a plan to put solar on the Tundra Buggy Lodge for summer use. That will actually offset any air conditioning that's required. We've already calculated the roof space for that and the south tilt. There's not much tilt required because there's like 20 hours of sunlight up there in the summer. So that would work very well for that. As far as the buggies, or any other time of year in Northern Lights, in Polar Bear season, the sun is just too low. There's very little of it. It's always gray. And so if it just wouldn't be a feasible addition that we've so far with where solar panels are at this point.
Is wind an option?
Wind is an option. It's very loud. So in terms of around polar bears and that, it would probably be more disturbing to them than anybody would want to disturb.
Okay, no, that's interesting. Like, you guys had shared a story with me that I thought was actually kind of interesting. Was when you brought your first EV Tundra Buggy out to the Tundra, out to the park, that the bears were actually confused because they associated diesel noise with these big white things on the Tundra, and you had them puzzled for a little while. How are the bears? Are they getting used to this, or what are you observing?
Yeah, I can speak to that. So a number of years ago, researchers from the University of Central Florida did a study on the impact of tourism on the polar bears. And this is, back in everything was full diesel. And the results of that study were that upon a first interaction, a bear could either turn around and run the other way, be oblivious and keep doing what they're doing, or come and sort of more closely inspect the bears. But after about 3 interactions, all bears treated Tundra Buggies as sort of a part of the landscape, and they didn't really give a rip about them. And interestingly, over the years, so what happens is, our guides, very important, is that we're not chasing polar bears or any other wildlife. The guides are going to set up in a position where it looks like the bear might be going in that direction anyways. So we kind of get ahead of them, shut everything down, stay quiet, and the bears will pass right on by. And some will just kind of flop down and maybe have a rest or sleep or a nappy poo. And so historically, the quarter turn on the ignition and the fuel pump starts click, 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 and then igniting the diesel engine, of course, that roars to life, is a very clear audio cue for those polar bears that this thing's about to move. And that's not the case with these EV Tundra Buggies. So we're actually we're working with a nonprofit polar bear conservation group called Polar Bears International, and in the early stages of designing a sound study that would look at not only just the tour area around Churchill, but around town, around other areas, around the airport, and just to kind of get a sound profile of what's going on and how wildlife are responding to all sorts of sounds around Churchill, including the tourism sounds. And what we've talked about, we haven't implemented yet, we're still getting our legs under us, so to speak, is should we or can we develop a sound suite for these Tundra Buggies? Like, for example, when you can hear a Toyota hybrid from a half a block away, there's a distinct sound that's not a combustion engine, but it's some sort of a sound that's being emitted. And we're considering, is there a sound that these EV Tundra buggies should be emitting just to let the wildlife know we're on our way or we're coming, that sort of thing.
Fascinating. So, Christian Koos, who's with the University of Manitoba and very interested in battery technology, says this is pretty awesome. I understand that the batteries are basically operating all the time between 5 degrees and 40 degrees C. So any specialized low temperature batteries would not provide significant advantage? Question mark. How long are the breaks in battery operation where they just sit idle?
So I guess I mean, there's low temperature batteries. I wonder if maybe he's speaking about solid state or something along those lines. I don't see the advantage at this point. I'm not saying there isn't, but I don't know enough about those batteries. As far as how long they may sit idle, it could a lot of the times it may be, during the day they're going to sit for an hour or 2 hours for lunch, maybe even up to 3 hours if they're seeing a lot of bear action. So during the day, there's more than enough, no matter the temperature, to not have to warm the batteries. If they're sitting for 3 to 4 days at a time, it would be very rare, but it might be at the beginning of bear season when they don't need heat anyway. And then the other thing is, after bear season, they're going to sit for, 3 months, and then after Northern Lights season, they're going to sit for another 3 months. So during that time, these batteries are designed, and we don't need to, but the batteries are designed to be stacked inside the shop, so there's no heating required. We just plug these in and run a small, basically a somewhat of a block heater that keeps them above -20. So it very rarely would run. That would be for December and January. We'll keep them basically around about -20. And when we're about to use them, from then on, they'll be above zero. It's not required. We're just abundantly caution of taking care of the batteries and not abusing them. And we have the space to unload all these batteries. They're all the same. They all stack on top of each other in the shop. If required, we haven't got there yet, but that's where we're at.
Excellent.
The one thing we talked about with those solid state batteries, Ty, wasn't it that we could just leave them outside unplugged and we didn't have to pay as close attention to them?
Exactly, yeah.
Oh, over the winter, yeah.
Yeah, it's kind of an emerging technology, though. It's not something that's quite readily available yet, right?
Yeah.
Next question. Is it feasible to make what you have fully electric in terms of technology and finance? It's one of the questions, too, that you notice that some of the transit bus manufacturers have diesel-fired heaters in order to keep passenger compartments warm and that kind of thing. Do you see any technology on the horizon that would enable you to go fully electric, or what do you think?
We would be using right now we have a 10 kilowatt heater on board that's probably used primarily in the last 3 to 4 weeks. So it's used about 4 weeks of bear season, so about half of it. That's also required to run to keep the because there is a washroom on board. It keeps water tanks warm and that kind of thing. For us to go fully electric, it's basically we would need 10 kilowatts times about 24 hours more battery power, which is basically double the battery bank. And these heaters to heat the entire cabin use about 1 liter per hour. So we're not doing too bad. There's definitely been talk about it. It adds a lot of space, which is something we're a little bit short of on these particular vehicles.
Yeah, I know that, in order to go fully electric, there are some in the transit world that have attempted to go fully electric with cabin heat, but it just kills range so badly that it just doesn't make a whole boatload of sense, right? And Yeah, I think, reducing emissions as much as they have is honorable, and we're talking about net zero, not zero, right? So sometimes we have to use technologies like this until something is developed that can heat a cab without using fossil fuels.
I think from a consumer standpoint, it strikes, our responsibility is to keep our guests feeling safe and actually safe, but feeling safe and comfortable. And the trade-off of having that small, diesel-fired space heater is that is an acceptable trade-off, right? When we got into this, we didn't know, if any of this is going to work, and the idea that like couching against what might have been some sort of catastrophic battery failure, we needed to keep our guests warm. So that was the motivation in the first place. Well, one of the motivations in the first place was it's to make sure we had that redundant heating supply and that we were able to fulfill that, essentially that promise of keeping our guests safe.
That's great. So now that you've got 2 power units, I'll call them, done, is there a ROI for Frontiers North on the development expense and the conversion expense to go EV versus staying diesel? What's your thoughts on that?
The thoughts are that when we were planning this webinar, I asked help from our finance team to define that, and I forgot to follow up on it. That's my thought. So I'll have to,
Yeah.
I'll have to go get that number, and we're happy to share it. But yes, the short answer is yes. I think sort of anecdotally, I kind of mentioned it earlier, is that, and maybe because Ty's running these crews, being able to speak to the reduction in daily maintenance required for the EVs. Can you speak to that for a second, Ty?
Yeah, especially in the extreme cold, we're running into spun bearings. No matter what oil we use, our injection pumps on the diesel engines are having real trouble with the amount of water that we just can't seem to get all of it out of the diesel that comes up to Churchill. Not to mention that diesel in Churchill is only summer diesel, if you can believe that. So we run into a lot of issues that way with the diesel engines themselves. And yeah, as far as maintaining, we're taking wet brakes, which are internal to the axles, and we're taking about 3 liters of power steering fluid onto the Tundra. There's no transmission fluid, there's no engine oil, there's none of that, which has been for our maintenance team a real headache if in that extreme cold, a hose doesn't want to send oil to the right location anymore. No matter what, that extreme cold does a number on fittings and hoses in terms of just shrinking and just not allowing the amount of bend or anything that's required on that kind of. So it's been a big reduction in any kind of just mitigating any kind of oil on the Tundra to start with, let alone us having to worry about that. So that part has been huge for our maintenance crew.
Mm-hmm.
Yeah, I remember when I was up there for the unveiling of the first buggy, you were talking about even the paperwork that has to happen if somebody spills a can of Coke over the side of the Tundra buggy onto and it's an environmentally sensitive place, right? And if you have a power steering hose blow or something like that, I can see that being quite the paperwork ordeal, put it that way.
And it's
not a good thing to begin with, but
it's not to be overlooked that we are working right next to polar bears on the ground if something does go wrong, and that's never fun because we don't generally have the ability to scare them off as there's guests around. So there's that part of it, which the less chance that we need to be on the ground, the better, which is very important to us.
Great.
Just a quick anecdote on that. A number of years ago in Wapusk National Park, we had an ATF spill. We kind of broke through a shallow lake, and we just had a big mess of transmission fluid, and the cleanup required for that. So now this is twice as far away from where we're normally operating. So about 70, 75 kilometers away from the community of Churchill. We had to essentially chainsaw out all that ice that was affected by the spill and transport those blocks back to Churchill and have them melt into like our trap in the garage. Like, it's just, we're eliminating a lot of those situations by just eliminating the fluids that we're taking out in the first place.
That's great. And I see a question here from Mike. Yeah, we talked about that a little earlier, that during some of the seasons when the sun's a little higher, that solar does, can be used, but in the winter it's so low that it's not really much of an advantage. With that, I'm not really seeing any other questions coming through. And just one last question I have is, when I was up there, I guess the driver we had during the initial Tundra Buggy, when you guys did that grand opening or whatever of it, he was like an 8-year-old at Christmas. He just absolutely was in love with that electric Tundra Buggy. What's been the reaction of your staff to now that you have more of these and the combined heat and power unit in the kitchen? How's your staff reacting?
Favorably. I think, folks are creatures of habit, and I think that a lot of the guides that we work with, we've been working with for well over a decade, some for over 2 decades. So the one that we're working on right now, we're converting Buggy 9 from diesel to EV, and it's going to go back up. And Jim, who's been driving Buggy 9 for pretty much 20 years, that's, there's going to be an adjustment, but he'll live. I think what's interesting is that there's an inset display on the dashboard of the touring Tundra Buggies. And, you go from all sort of like this steampunk gauges and whistles and everything, and you go down to one inset display, which is cool. But what we had on the display was a big battery showing how much battery was left. And one of the things that ended up sort of, you're on a Tundra Buggy and you've got 20 guests behind you, and everybody was just sort of like mesmerized by the battery indicator and how much power we have left, and are we going to get back? So we had to make that smaller and hide it a little bit so it wasn't much of a distraction. But I think overall, like in terms of response from our team, our ability to attract staff and team members who sort of buy into our values as a company, is it's a lot. It's difficult to articulate something like, what is a B Corp certification? What's a B Corp? What do you mean business for a force for good? And something like an EV Tundra Buggy is a really good sort of symbol of what that represents. So it definitely helped us in our ability to attract and retain great staff, the people that we want to work with. And it's definitely, although there's an expense on the front end, our internal goal has been greenhouse gas emissions reductions. Some guests are really interested in that. Some guests don't care about that at all. But what everybody can agree upon is that silently navigating under the northern lights or amongst wild polar bears is pretty flippin' cool. So it's the projects have been very, very well received by staff and guests alike.
Well, and that's a great point to end this webinar, John and Ty. Thank you very much for your time. And we'll be posting this website or this webinar on the BTC website. Should have it up later this afternoon. So thanks again. Appreciate your time, and thanks to all that have joined us. Have a great day.
Thanks, everybody.
Thanks, John.
Yep. Thanks, Ty.